Breast cancer begins with the gradual loss of control over growth and genomic stability in mammary epithelial cells. Early on, defects in DNA repair, sometimes inherited, as with BRCA1 and BRCA2, allow mutations to accumulate. As damage builds, critical regulatory systems begin to fail. Loss of tumour suppressors like TP53 removes cell cycle checkpoints and apoptotic control, while activation of growth pathways such as HER2, signalling via ERBB2 or PI3K pathway activation drives persistent proliferation and survival. In many tumours, estrogen signalling through ESR1 further amplifies this process, creating sustained transcriptional programs for cell division. As these cells expand, the tumour becomes heterogeneous. Subclones compete and evolve under selective pressures, hypoxia, immune surveillance, and limited nutrients. Cells that evade immune detection, resist apoptosis, and adapt metabolically begin to dominate. At the same time, the surrounding microenvironment is reshaped. Fibroblasts become tumour supportive. Blood vessels form to supply oxygen. And immune cells may shift from defence to tolerance. Eventually, some cells acquire invasive capabilities, losing adhesion, degrading surrounding matrix, and entering the circulation. A small fraction survive to colonise distant tissues. This is metastasis, the primary driver of mortality. Importantly, different breast cancers reflect different dominant pathways, hormone receptor-driven, HER2 amplified, or more genomically unstable subtypes, each with distinct therapeutic vulnerabilities. What we call breast cancer is therefore not a single entity, but a dynamic, evolving network of disrupted signalling, progressing from local dysregulation to systemic disease.